Okay, so this is particularly for period 6. So this is to help you get your major grade project done if you need help working through those calculations. Okay, so what are you going to need? You are going to need a little purple sheet like this. If you don't have that purple sheet, then you can write your calculations on a separate sheet of paper or look at my website. Okay, and then you can also go over here. Make sure that you've got your blue periodic table that's got your particles, grams. Okay, so that's what we're going to be using, grams to moles to particles. All right, so let's look at the purple sheet. What does this want you to do today? So the first question is just asking you about how many atoms are in 1 mole of aluminum. Well, that's easy. That's Avogadro's number, okay? And you can find that right on that mole map right there, okay? Look at the particles section. How many particles are in 1 mole? Right there, 6.02 times 10 to the 23rd particles. That's the number of particles in 1 mole of any substance. So that is what you need to write right there in that first line. That's Avogadro's number. How many grams would 1 mole of aluminum contain? Okay, here is where you need to go back to the mole map, right? Or think about what we learned in class. 1 mole is molar mass. Okay, where do we find the molar mass? Oh, right, that's on the periodic table. So, go back to the periodic table and look up aluminum. Remember on the periodic table in class, what color were all the molar masses? Red, that's right. Well, on your periodic table, they're not in red, but you can look on your periodic table or one on the map on the web, and look, there's the mass of aluminum, 26.982. Okay, so you're going to take that number and write it here on your project sheet. So you're going to write the molar mass of aluminum. Okay, what's the symbol for aluminum? Al. Okay, so you're going to write that molar mass out, and what is the unit for molar mass? Grams per mole. Okay. All right, now your object. You were supposed to have made an object in class and taken the mass. So I hope you remember what you made and you can describe what it is. Okay, I'm going to use this object that somebody else made, right? They've got an apple. So I would write apple here. Okay, you need to describe whatever you made and then write that there. Look, and if you do all of those things, you've actually got 20 points already. Okay, what is the mass of your object? Measure it to the nearest 100th place. What does that mean? When you do your mass, let's say that I had 7 grams, okay, and it fell about halfway between 7 and 8. Okay, so that would be the 10th place. And what if it fell halfway between the smaller increments? That would be 7.55. Okay, so I need to do 2 places after the decimal. What if it was right on the 7? That would be 7.00. Okay, those are just examples. You need to find your own mass. If you didn't take the mass in class, then what you should do is take your object, and maybe your parents have a kitchen scale you could use. And if they don't, well, the post office does. So you could go there and take the mass. Okay? Okay, so you got your object's mass. We're going to call that your object's mass. You need to have that and write it down. Okay? So wherever I put YOM, you need to put in your own object's mass. Okay. So you're going to show the work with dimensional analysis in units. How many moles of aluminum make your object? We have to go from grams to moles. Do you remember how many boxes we need for that? Let's look at the mole map. Okay, so here's grams and here's moles. We need to make one step from grams to moles, and then we need a place for the given. So remember, if we're going from grams to moles, we're going to divide by the molar mass. Okay, so let's set that up. 2 boxes. Make them kind of large so you have plenty of space. Okay, what are we starting with? It says grams. So grams goes here. And we want to go from grams to moles. So remember, disco the starting unit down. Put what you want to find on top. Okay, and moles always gets what number in this unit? 1. Okay, so it says how many moles of aluminum make up your object? All right, well, what did we start with? Your mass. So you're going to take your object's mass, right? You're going to fill that in right here. And we're going to take that and divide it by the mass of aluminum. So what do you think? Will your object be more or less than 1 mole? Most of the time it'll be less, right? Because aluminum is pretty light and you're making a small object. So what is that mass of aluminum? Remember, you should have written it already up top. If you didn't, go back to the periodic table and find the mass of aluminum, 26.982. Yes, if you really want to, you can round it to 27. Okay, so we're going to take your object's mass, divide it by 26.982, and write your answer here. What is your unit? Well, grams and grams cancel, so it's going to be moles of aluminum. Okay, so fill that in. Look, that gives you 15 more points. Next, it says to convert grams to atoms. So let's see where that takes us on the mole map. Grams going all the way. Where are atoms? They don't show up on here. Right, we have to read the fine print. Look, particles, atoms, molecules, and formula units are all here. So atoms are a type of particle. So grams to moles to particles. It says to get from grams to moles, we divide by the molar mass. To get from moles to particles, we times by Avogadro's number. So let's set that up. That means we need our given and 2 steps for a total of 3 boxes. Okay, so, it's talking about your object in grams, right? So we're going to start out with your object's mass in grams. Disco the grams down, but not the number, just the unit. Okay, we know we need to go from grams to moles because that's how it goes in the periodic table, right? Grams to moles. What number does moles always get? 1. Take your moles and put it down here. In this unit, moles gets a 1. Up here, what are we trying to find? Atoms. Okay, let's look at the mole map and see what number atoms should get. Atoms are a particle, so they are always 6.02 times 10 to the 23rd. So let's fill that in. Okay, now what about those grams? Remember, your object is made out of aluminum, so this is going to be the molar mass of aluminum again, right? We already wrote that in the other problem, so you should be able to fill that in yourself. So what are you going to do to calculate this? Well, the first step is to take your object's mass, you divide it by the molar mass of aluminum, and then hit enter. That answer you're going to multiply times 6.02 EE23. Remember, you don't put in the times 10. The EE or EXP button on your calculator will tell you that it means times 10. Okay? So divide, enter, then multiply by Avogadro's number. What unit do we have at the end? It's going to be atoms of aluminum. Okay, so you're going to fill that in. Now, the next problem is asking you to apply this type of calculation and see if you can do the calculation with another substance. So it says, if a sample of Epsom salts or magnesium sulfate had the same mass as your object, how many moles of magnesium sulfate would there be? Grams to moles. Okay, well, we've done this before, right? Grams to moles, you've got to divide by the molar mass. So we know that's going to be 2 boxes. Okay, grams, grams, and then we're going to get to moles on top. We know that moles gets a 1. Now, what are we starting out with? It says if the sample had the same mass as your object. So that's what we need to start out with. Your object's mass. Now, we want to know how many moles of magnesium sulfate there would be. So that means we need to use the molar mass of magnesium sulfate. Okay, is this just magnesium and sulfur? Well, we need to write the formula to find that out. So let's think about it. Okay, magnesium, that's just Mg. Okay, and then sulfate, that's not just on the periodic table. Remember, your 8s and your ites are on the polyatomic chart. So you should use your blue sheet. Okay, and then you're going to go look on your polyatomic chart. And you're going to find, oh, there's sulfate right down at the bottom, SO4 minus 2. So we're going to write that in, SO4. So this is a plus 2, and that's a minus 2. The rule when your ions have the same number, an opposite charge, is that they cancel. So we don't need the charges, we don't need any new subscripts. So that's our formula. Okay, look back on the periodic table. Magnesium, it weighs 24. Sulfur weighs 32. We have 4 oxygens. If each oxygen is 16 times 4, that's going to give us 64. Okay, so you need to find that mass and add them up and get that number. And when you have that molar mass of magnesium sulfate, you're going to fill that in right over here. So I'm going to write that. Molar mass of MgSO4. So you need to calculate this molar mass and fill it in here. Okay? Is the mass of magnesium sulfate, 1 mole of that, more than aluminum? Yeah, it weighs a lot more, right? So you'll probably have a smaller answer over here in terms of your moles of MgSO4. Okay, last one. This one says, if copper weather vane had the same mass as your project, how many atoms of copper would be in the copper weather vane? All right, it says grams to atoms. Have we done this before? Right? Which problem is it like? It's just like this one, except you need to use copper, okay? So you can fill that in with how many boxes? Okay, so it says the same mass as your project, right? So you're going to need to start out with your own object's mass right there. Then, what are you going to do down here? Well, it says grams of what? Ooh, copper this time. Okay, so you're going to start out with your object's mass. We want to compare that to the what of copper? The molar mass. You're going to fill that in from the periodic table. So look at copper and find its molar mass. Whenever we use the molar mass, it's the grams in how many moles? 1 mole. 1 mole. Okay, now we can go from moles to atoms. And what number needs to go with atoms? Look at the problem up here. What did we write? Avogadro's number, right? That's what you need to put here. Then you're going to take your object's mass divided by the molar mass of copper from the periodic table, hit enter, and then you're going to multiply it times Avogadro's number. So you need to fill these in and do the calculations. And then you're going to tell me how many atoms of copper you have. And when you get that done, you will have your major project grade done. And if you turn it into me when you get back from break, you should be able to have 100. So good luck with that, and I hope you have a happy Thanksgiving.